So today's video is called Using Formulas. So what is a formula? A formula is a set of instructions for creating a desired result. So basically it's giving you step-by-step instructions for getting to a certain point. And when do we use formulas? They are commonly used in math, and they're even more commonly used in science. So here's some examples of some formula, and there are thousands of formulas, so these are just a couple. One formula you might be familiar with is the formula to find the area of a rectangle. So you know that in order to find the area of a rectangle, you multiply the length times the width. And no matter what the length is and no matter what the width is, you just plug that in, multiply them together, and that gives you the area. Well, that's called a formula because it tells you how to find the area of a rectangle. Another formula is if you want to find out how far something or someone traveled. So if you want to find their distance, well, you can take how fast they're going times and multiply that with how long they're traveling, and it will tell you how far they're going, or it will tell you their distance. So that's another formula. And another formula is density. So I know you guys did density in science, and density has a formula. So you can actually use a formula to actually find the density of an object. So you can actually take the mass of an object and divide it by the volume, and it will give you the density of the object. So let's look at some examples. So our first example is we're going to be using the formula for area. So I have this rectangle here, and it has a width of 3 and a length of 8. So I know the formula is do length times width, and you can find the area of this rectangle. So I'm going to plug in for the length 8, and then for the width I'm going to plug in 3, and then I'm going to multiply those together, which means that my area is going to equal 24. So then that means the area is 24 inches squared. So then I have a different rectangle, but we're going to use the same formula. So basically I'm showing you how no matter what the rectangle is, the formula doesn't change. So we're still going to do length times width, only this time the length is 2 millimeters, and the length is 9 millimeters, and the width is 2 millimeters. So again, I'm going to plug 9 in for my length, and I'm going to plug 2 in for my width. And then that's going to give me the area. So the area is going to equal 18. So the area of this rectangle is 18 inches squared. And then even when I have a square, well, one thing we know about a square is that all 4 sides are the same, which means the length and the width are the same. So you're still finding the area using the same formula, length times width, only this time you know that the length is going to be 12, and you know that the width is also going to be 12. So then you're going to multiply 12 times 12, and that's going to give you an area of 144, which means the area of this square is 144 inches squared. So what I wanted you to see is that the formula doesn't change even if the shapes do. So even though the information we're plugging into the formula changed, the actual formula, area equals length times width, stayed the same. And that's why it's called a formula, because a formula doesn't change. It just means that this is how you find area. This is the steps you take to find area. So another example is when we're doing distance. So in this example, you traveled 2 miles per hour on your new bike. How far will you have traveled after 3 hours? And we're going to use the formula distance equals rate times time. So first you have to understand what rate is. And rate is how fast you're going. So in our problem, it tells us that we're going 2 miles per hour. So that's our rate. And then the time is how long you're riding the bike. And we're riding our bike for 3 hours. So we're going to use this formula, distance equals rate times time. And now what we're going to do is we're going to plug in our rate. So we know our rate is 2. And then for the time, we're going to plug in 3 because that's how long that we've been riding the bike. And to find how far we traveled, we multiply those together and we end up with 6. So that means in 3 hours, we will have traveled 6 miles on our bike. That would be our distance. So again, even if I changed the rate and the time, the formula stays the same. So another example, this example, we have an object that has a mass of 24 grams and a volume of 3 liters. What is the density of the object? So we're using the formula density equals mass divided by volume. So of course we want to start with plugging in our mass. Then the next thing we want to do is plug in our volume, and the volume is 3. And then if we want to find the density of the object, we simply need to divide 24 by 3, and that gives us 8. So that means the density of the object is 8 grams per liter. So again, if I had a different object, I could plug in the mass and the volume of the different object, and I would still use the same formula. So formulas don't change, just the information you plug into them can change. So the one thing you want to make sure that you're understanding with formulas is that when you're using a formula, you got to make sure that you understand what the different parts of the formula are. And then once you know the different parts, you got to make sure that you're plugging in the right information to get your desired results, whatever it is that you're looking for, whether it's distance, whether you're trying to find area, whether you're trying to find density. It doesn't matter. You just need to make sure you know what the formula is for all those different things, and then make sure you plug in the right information. So go ahead and teach the tiger something you learned in today's video.